Okay, good morning. Let's remember what we did on Friday. We started dividing radicals. You only need to pay attention to three requirements. What are those requirements? Does this. So when you're dividing two radicals, you know when to stop if all three requirements have been met. And those requirements are here we go. First, there should be no big powers left inside. So if there are rich prisoners, they break prison by paying off. You need to get them out. Second, no ratios inside the radical. Third, no radicals in the denominator. And this was the most tricky part, maybe hardest part of simplifying a radical. And this is called rationalization. That's this topic today actually. Whenever you have a radical in the denominator, you can't leave your answer like that. We need to get rid of that prison around the inmates. And that's what we're going to cover today. But again, when you have a fraction inside the denominator, all you need to do is you need to separate into two radicals. If you have a number with high enough power, you need to take it out by division and remainder procedure. And we have done all that several times. We were about to start, we actually started rationalizing. You cannot leave your answer with a radical in the denominator. If you have a radical in the denominator, you must multiply both sides with the same radical index. But you need to arrange the terms inside the radical according to what you have already in the denominator. So if this is 5, you take 5, you need to guess how many 5s do you need to make this guy rich enough to break prison. Rich enough means you need $2. You already have a single 5. I know that I need to bring one more guy next to this so I can make 2 of them so you can break prison, right? So that's how we did number 5. And we also did number 6. Next time you need $4 to break prison. Z has only 1. And how many Z's did you bring next to this Z? We had 3. So altogether we combined these two prisons into 1. Z to the first, Z to the cube made all 4. Here though, they won't combine, you just put them next to each other. Because this is a whole number, this is a radical. So whole radical combination happens on the top. And these two cancel each other because 4 goes into 4 once. So Z to the 1 comes out. Or you don't have to show 1, it's just Z. And nobody left inside, so all the radical disappears. But the top will have something with a radical. Because we cannot compute. 3 is not big enough to break prison, so you have Z cubed stuck inside. So this is how you rationalize it. So this is not rationalized yet. This is rationalized because I have no longer a radical in the denominator. And this is our final answer. Alright, we're going to start off similar work, and then get this thing rationalized. So what term do you need this 4th radical 8w squared to multiply with so that 8 and w squared all will break prison?
We could just do w squared and then turn 2 cubed.
Yeah. First step is, this is the difference in this question is, here you had only one variable, one type inmate, it was only Z. Here you have a combination of W and a number combination. There are two inmates you need to save out of prison here. It's not just one. So you need to save W and H separately. To get W out of this prison, how many more W's do you need? You already have two. So you need to make them 4. You need 2 more. That takes care of W. How about 8? You need to save 8 out of this prison as well. So you need to bring more guys like 8 here so that they can all come together. To figure this out, first break 8 into factors. 8 breaks into factors 4 and 2, and 4 breaks into another pair of 2's. 8 actually is triple 2. It's 2 cubed. So this is 2 with $3 in pocket, but you need 4. So how many more 2's do you need? Just 1, 2 to the first. So it's 2W squared is what you need. Again, this is 3. You're a little short. I need 1 more to make them 4. This is all you need to do in number 7. You don't have to do anything else. So I will stop here. It just says fill in the blanks. We just discover what we need. We need 2W squared. So you don't have to compute all the way to the end. We will do it in the next question, don't worry. I'm just checking if you can spot what's missing and can identify what both sides will multiply with. We did, right? Does it make sense? Now we are really doing all the way. Again, it directly says rationalize the denominator. Rationalizing denominator means get rid of this prism or roof around 3x. Get this out, 3 and x, out of this prism. So you guys need to multiply both sides with something. So tell me, what do we need to multiply top and bottom with? I believe it's going to be same type prism. What is it? 3. So that this can become a pair and make $2. And x. Good. So easy, right? This was a no-brainer because you already have 1 of each kind. You need 2 of each kind. I need 2, 3 with a square, x with a square. So I bring 1 more of those guys. And that's it. So is this what we are gonna put down here? No. They don't say just identify. They don't say just fill in. They say go all the way and compute this, simplify this, make it this square root disappear. So you need to multiply now side by side. That's it. 6 multiplying 3x, radical 3x, and these guys will multiply, of course. I will do this in baby steps, really, step by step. So you first bring these together, and then you join the prisons, because this is a multiplication, same type prison. So you join the prisons and prisoners. Oh, what a coincidence. You have same type of inmate twice. So it is 3 squared. This is 3 squared and x squared. Top doesn't change at all. And guess what? This 3 squared comes out, x squared comes out with giving up their powers. Because 2 goes into 2 once. This is gone. X squared goes into 2 goes into 2 once again. Nothing remains. 0 remains. 1, 3 and 1x comes out. Right? And we have on the top 6, 3x. On the bottom only 3 and x. Look, 3 and x. Are we done? We have actually accomplished what they requested. Do you see any radicals in the denominator anymore? That's what rationalizing means. No radical in the denominator. I did it. But I'm not sure ConnectMan is gonna accept this answer, because whenever I rationalize, I need to simplify. It doesn't say simplify though, so that I'm suspicious. It doesn't say simplify. Rationalize it, but I know you can do one more step and simplify this better. What do you see? What can you simplify here? Look, there is a common factor of top and bottom. 6 and 3 are both divisible by 3. So can I divide both by 3 and get rid of this? So it is 2 root 3x over x only. Okay? Oh, I can do better. I have a pair of x's matching. Can I cancel them? No. One is inside prison, the other guy is a free guy. How can you kill them? Can a free guy go into prison and kill an inmate? No, there are walls, barriers, right? So you can't kill them. One is inside, one is out, so they are not the same type, so you cannot cancel more. This is it. 6 and 3 cancels because they are both out. So this is the best answer. I want you to substitute, but I'm just curious if the earlier result was accepted or not. It shouldn't be accepted, to be honest. So it is 6 on the top, radical 3x, and bottom 3x, right? Yeah, good. It didn't like it. Should be on it too then. It should be none. So although it doesn't say in rationalizing, you automatically need to simplify all the way to through the end. Okay. Now we're good. All right. Here comes the next question. This time there are no variables to save from prism, but all numbers. Question is, what shall we multiply 25 with, both top and bottom, so you can have no radical? Rationalize means no radical again in the denominator. Tell me. I know it's gonna be a radical, but first let's identify the index. What will be the index of these radicals each? Of course it's gonna be 3, right? Needs to be same type prism. What number 25 should multiply so it can be perfectly pay off this $3 amount? What?
Well, if you turn down the 5 squared on the left, so you times it by 5 to get 5.
Yes, always prepare this number, break up and factor it into powers. 25 is 5 times 5, so it's already 5 squared. So take this one off, don't take it as it is, prepare it and make it a power, factor it and make powers visible, fully visible. So this was not 25 actually, it was 5 squared. Now this makes more sense, because this guy has $2 already, he needs $3. So how many more 5s do you need to put here? Just 1. One more and you're good. Look, I'm doing it already. 2. One more, you have altogether 3. On the top, you just join them each other, bring them each other. 6 cube root 5. Cancel, cancel. Look, if these two match, this is what I do. I just wipe it off. Wipe off the prism. No more prism. 5 is exposed. 5 is free. Again, why am I doing this? Because 3 goes into 3 and nothing left. This is the math you do actually in the background. 3 goes into 3 once. 0 prisoner left, so that's why I don't have 0. But 1 5, 1 here shows up, 1 5. But you don't have to make this one visible, okay? This is the background I'm doing. And to save time, always I'm crossing these off. Any more cancellations? Can you always ask this question? Now there are free guys exposed from this radical. There are already free guys on the top. Can I cancel these and make it simpler? 6 and 5, can I cancel anything among them? No. So this is it. Make sense? Alright. Now, please take a look at the last 4 questions we checked out today. All the time in the denominator was a single term. Single, 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 single radical, right? Nothing beside the radical. Yeah, inside was crowded. You have inmates inside, like sometimes two different type inside. But around the radical, nothing I observed. Just the radical, but nothing else. What is different now? Come look at this question. How many terms do you see in the denominator? What do you have around the radical? Do you have single radical again? No. We have something else. Although it's a whole number, free guy, no more radicals, but a free guy, it still counts two terms here. For such a case, if you have 2 terms in the denominator, very important, 2 terms, just multiplying, most people think, oh, I just need to multiply both sides with the same radical, won't work. It's not just same radical on the top and bottom. It's something we call conjugate. So whenever you see 2 terms, you need to remember this word, conjugate. A terrible speller. Conjugate multiplication is required. What does conjugate means? It's just, look, it's very simple. Flipping this sign to opposite and putting that entire 2 terms, top and bottom. That's what conjugate means. Conjugate means take these 2 terms with opposite signs in between. 2 terms, look, 2 root 6 with opposite sign. Okay? Alright, why do you think we're multiplying with conjugates? Look, these are conjugates. Why? Why they choose opposite and multiply both sides? Because of this. Look, when you multiply 2 conjugates, their multiplication do not recur. Usually the long way is FOIL. You need to FOIL and spend a couple minutes to do that. No, if you choose conjugates, you don't have to FOIL. If the only difference between these 2 terms is the sign between, their multiplication is just square of them with a sign minus in between. This is also called square difference. Square difference formula. Look how quickly you can multiply these. We do not require foiling. Can you do foiling still? Yes, you can, but not necessary.
What's the steps that you're doing just to the right of where your cursor is? That's getting rid of the square root symbol over 6.
Yeah. So we first put squares. Okay, you got that part right, and we put a minus. Now, how did they come to here?
Is it because of the 2 in the power of the 2? The index is 2.
Yeah. Because this has index 2, and whenever you have an outside power of a radical, you can actually move into the 6 here and make this 6 with a square and index 2. Oh, they have the exact change. They say cancel. Or why can I move a number like this inside? This is the long story here. Square means double. Whatever you have underneath, you need to double it. What happens if you double this thing? You have 2 prisons twice with same inmates, right? Well, how can I combine 2 prisons? You move the prisoners into under the same roof, right? And that's the reason we have a double. How you move this 2 is explained here. They cancel and get 6 as well. Okay? But going back to this again, whenever you have conjugates, I mean same pair with opposite signs, you put the minus in between first. You square the first. Take this, square it. You square the second. First square, second square, that's it. Root 6 squared, 2 squared, and a minus between. You either take this first and second, or you take this first and second, because they are the same thing. 2 and root 6, same. 2 squared is 4, root 6, 6 squared is 6, 4 minus 6 is minus 2. That's how they got this answer, minus 2. But you multiply the top as well, it's just distribution. Distribute the tops. Minus 2 times 2 is minus 4. No, you actually don't wait. No, wait. Don't distribute yet unless it's necessary. You are here now, right? You combine these two. Minus 2 times root 2 minus root 6. And on the bottom you multiply those here and got minus 2 here. There you go, minus 2. You combine the tops. First simplify if they do simplify. You see, they didn't distribute, they simplified first. Then if there is any leftover here, anything left, then you distribute it, okay? So don't rush to multiply as I tried to do. Don't distribute yet. First compute bottom, cancel if there are any common factors. Then if there are still anything left, then distribute, okay? Alright, this is one example, but remember, we will do it again, alright? Same kind of example right here. Let's first warm up. So I'm not going directly solving a question. This is a 2-second question. What is the conjugate of this? What is conjugate of root 5 plus root 7? Right. You repeat both terms, but flip this sign. That's what the conjugate of two terms is. Oh, this wasn't a whole number like before. It wasn't 2. Do we care? No. It can be, both can be radical. One of them can be whole. First one can be whole, or the second one can be a whole number. I don't care what type of things I have around the plus. As long as you have two terms, 1 and 2, when they ask conjugate, I repeat them with the opposite sign. Okay? What is the conjugate of 18 minus root x? Do I care? Oh, this is an x, a radical, this is a whole number. The only thing matters is counting. Count. Do you have two terms with a plus or minus in between? Yes, so you can find its conjugate by putting a plus in between. That's it. Here's the conjugate. Okay? So 17, 11 and 12 are just 2-second questions. 13, you not only find conjugate, you need to use that conjugate to rationalize this thing. Again, most people think, oh, this is the problem point. To solve it, I need to multiply both sides by the same thing. So you can get double. Wrong. Why? You cannot do this because this is a two-term denominator. Two-term. You can't just pick the radical and multiply both sides. You need to multiply both sides by conjugate. So I will show you that here. So tell me please, what is that conjugate I need to put both sides? 4 root 3 with a minus. Please do use parentheses abundantly. There is no harm to put parentheses whenever you wish, okay? Alright, can we combine both sides? Like, just move these next to each other. Okay? Alright, what is next? We will first multiply the denominator. Multiply. Oh, we need to FOIL this, right? Yes, you can FOIL it, but that's a long way. How do I get that quickly? How do I get this bottom quickly? Square the first, second, either first or second. Square each. Square the first, square the second, and what shall we put inside? It's always plus, right? Because they are squares. Squares make things plus, right? No, rule doesn't say that. Rule says square first, square second, and put what? It's always the minus. Square first, square second term, and put a minus in between. It's called square difference formula. They would say square sum formula if this would be a plus. Okay? Alright. Now, can you guys square 4? What is it? What is square root of root 3? They cancel away because 2 actually moves inside and cancel that way, but I can do it right outside like that. What is 16 take away 3? 16 minus 3 is 13. What shall we do about the top? What is next? Usually, don't rush to distribute this. Don't. What do we need to seek for? See if these two cancel somehow. Can you cancel 6 and 13 among them? Anything common? Any common factors? Can you cancel 6 and 13? I wish this was 12. 6 goes to 12 twice. I could do that, but not with this. Okay? So you can leave your answer like this, or you can distribute this 6 to both sides and make this 24. 6 times 4 is 24. 6 times root 3 is 6 root 3. Okay? I want to try the first one first. Make sure it's doable. This is the original format, and then I distribute it. See if it's gonna like it. Yeah, it liked this one too. But again, you can distribute this and make this 24. Take away 6 root 3. And still likes it, even though I have a parentheses. Either answer is acceptable, okay? This or this. Okay, I want you to give a moment, take a couple minutes and work on this question and fail. Okay? I'll give you a chance to fail. Anybody wants to submit an answer for a credit? Alright. Let me move the question here. So we definitely need to multiply top and bottom with something. It's called conjugate. So what is the conjugate of 4 root 5 plus 7? Yes? What is it?
Minus 7.
Yeah. Copy all denominator. And you're doing that. Leave out the sign in between. Just put it back with opposite. minus, copy, both sides must get the same pair. Same sign, same pair. Okay? And use parentheses always around all terms unless it's a single. I didn't use parentheses around this guy because it was a single one. That's why. This one is double. This is double. I use parentheses. So look. I now move them together, bring them together into the same numerator. And multiply. Stop multiplying. Okay, I call this fast, this is long. Why? Look, they are same type multiplications. 2 by 2. 2 versus 2 term. 2 versus 2 term. Why is this fast, this is long? Yeah. This bottom one is conjugate multiplication. Because they are the same pair. Look, root 4 root 5, 4 root 5, 7 root 7, root 7, same pairs. But only thing different is the sign. They are called conjugate. I know the fast way. Square of first, square of second to multiply them. The top, most people think, oh, we just need to square these. No. This one requires foiling, guys. Because they are not the same pair. They are not conjugates. You need to FOIL first, last, outside terms, inside terms, last terms. Do for multiplication. Okay? So the top is gonna take a while. So I need something long. So let's get the first terms. First terms is 2 root 5, 4 root 5. 2 root 5 and then 4 root 5. This is F. First terms. O. What is O? O as in outside terms. These are outside terms. It's a minus because this is plus and minus makes a minus. 2 root 5 root 7. This is O. I. Inside terms. This is I. Minus plus makes minus root 7 4 root 5. L. Last terms. Minus minus makes plus root 7 root 7. Double root 7 plus. Do you see how slowly I'm doing this? That's how slow you must be as well. Yeah, after solving 5 questions like this, you can speed up. But there is only one right answer. Accepted. You need to go really slow. It's a long procedure, like I did. Use colored pencils as well. I don't care. But do slow down. Alright, how about the bottom? The bottom is easy. Square of the first term. Look, I'm putting a square around the first term. And the square minus square of the second term. Put a square around the second term. That's it. A squared minus B squared. A squared minus B squared. Got it? Are we good? Next. Multiply things on the top. F. I have whole parts. Look, these whole free numbers. Free numbers multiply each other first. 2 times 4 is 8. And then we combine the prisons. Here is one prison. Here's second. Are they the same type, same index? Yes, both square root. So I will join 5 and 5. They make 5 squared. And 5 squared will break prison as 5. Look, these two make root 5 squared. But root 5 squared is 5. So I have 8 times 5 there coming up, which is 40, of course. Minus free guy, no free guy to multiply, so I just put it like that. And then I need to join these two prisons. One inmate has 5, the other inmate is 7. So 5 times 7 makes 35. That's O. I mean, you may count this as 1 if you want. But this one has free guy 1, this one has 4. Minus 1 times 4 is minus 4. But again, the same prisons. Root 7 and root 5 combines to root 35. And the last one, look at this. They make 7 square when they join. You combine the prisons, same inmates, so double. When you have a double of a number, they cancel to 7. The last one is 7. Okay, how do I square free guy and inmate situation, free and prison? How do I square it? Anyone? Is it just you pass 2 to this guy's 5 square, it breaks prison? No. Squared not only doubles the prison and make 5 square, it also doubles 4 and it makes 16. So this is 16 and 5 with a square inside. Now wait a second, they cancel. And this thing becomes 5. Right? 5 comes out because it has $2, you have $2 here. And that makes 80 technically. 5 times 16 is 80. You should be all getting numbers. That's the idea behind rationalizing. When you are things multiplied in the denominator, you should have nothing but numbers. If you are still having a radical in the denominator here, you're doing it wrong. You did some mistake, go fix it. Alright, what is square root of 7? When I pass the square in, 7 square, and this cancels and makes only 7. Agree? So in the denominator, let me take the easy part out. 80 minus 7 is what you have, that's 73. 80 take away 7. How about the top? Can I clean up the top? Can you combine any like terms, any like stuff do you see on the top? You should.
40%.
Yep. These are like. So they make 47. What else? What's that? Yeah. You have minus 2 and minus 4 of the same apples. You have minus 2 apples, minus 4 more apples. How many apples do you have? These are like radicals. The only way you can add radicals is they have the same prison with same inmates. They are the same. Look, same apples, but different quantities of them. How many in total? Minus 6 of those 35 root 35s or apples. Okay? Can I break 35 and save some out of prison? 35?
Would 35 become squared because you're combining the two?
No. Again, when you are adding radicals, you just copy one, you don't double them. Okay? So it's just single 35. But my question is, can I break 35 to factors and maybe get some squares out of it? Now 35 breaks only into two numbers, 5 and 7. They are each of a kind. You don't have double of them. We can't simplify more. The next thing you can search for is anything can be cancelled among this 47, 6 and 73. 73 is a prime number. It won't factor. 47 is prime as well. So they won't divide 6, 73 or 47, 73. They don't have any, they don't share any common factors. So this is our final answer. Make sense? Okay, we skip number 14, I believe, because it's very similar to 13. I did the difficult one for you, but you just watched, I think. But I need you to really try this question several times. Solve it once, get the right answer, and hit the button, try another, solve it another one, and third time until you get really fast and comfortable with this question. Was it 47 minus 6 root 35 over 73? Good. So who's gonna do number 14? You guys will. Alright, do it and turn it in. Alright, please don't use computers, okay? So switch off your computers. Don't peek at the solution, okay? This is very similar to this question. That's why I'm asking. Do you see how similar we just solved 13 and this? So you should be doing. I just want to check if you can do it, alright?